Welcome to Magnalytix here at SMTAI. Delighted to be joined by Mike Bixenman. Great to see you again, Mike.
Yeah, great to see you, Terry.
Yeah. So, the last time we looked at Magnalytix, you had, I think you were just coming out with your first version of this test chamber. It's come on a long way since then. It's full of new features. So, I'll let you explain to our viewers, some of the updates you've made to the test chamber and system in recent months and years.
Well, first of all, what we're trying to do is, this is a surface insulation resistance tester.
Yeah.
And so when you look at a printed circuit card, that printed circuit card is soldered with alloys. You have a component that you're soldering to the board. Mm-hmm. And typically, all these soldering materials have a flux component. And when you solder that board to the component, that flux residue could be active, it could be benign, it could be trapped underneath the component that should be benign but is active. And so what surface insulation resistance does is that it's a stress test. We're trying to expose a test substrate to temperature, humidity, and then we create the electrical field by creating a bias onto that test card.
Okay.
And so we're routing sensors of opposite polarity between the pads to say, does any of that residue that's left behind on the board, does it cause a reliability issue? Mm-hmm. Surface insulation resistance has been around for a long time. It's been known as the gold standard.
Yep.
It tells you the effects of any contamination that would be on a printed circuit card. As the changes in the J standard occurred and as we get to smaller components, the idea of using temperature, humidity, and bias is where companies are migrating toward. It's the best test to understand that type of reliability. Mm-hmm. So as we look at SIR test equipment that's been out for many years, it requires an electrometer, it requires a power supply,
yep.
And then typically you need other pieces to run that test. You need cables, high impedance, you need a chamber that's going to allow the board to be at a certain temperature, humidity, and bias.
Yep.
And so typically customers would have to go out and source those different pieces to actually create their unit. And most companies who have been doing this have been reliability labs.
Right. So they've been using PhDs to do it.
That's correct.
Yeah.
But what we tried to do is, it's a very functional test. Mm-hmm. It can be used for both qualification and process control. But the real magic is integrating it into the whole product.
Right.
And part of the whole product is being able to have software, making it a smart machine. Mm-hmm. So as the testing goes through, it basically, after each data point, it updates through the software, and a technician can run this machine. You can set it up, and the software gives you all the features to configure whatever conditions that you want to run the test at. Mm-hmm. So what we've done is we've taken this gold standard test and we simplified it, and our real goal is to be able to take it to the production floor to where
right.
customers can use it for both running qualification and process control
right.
on their circuit cards.
Yeah. And so essentially you've got an all-in-one SIR testing system here in this unit behind us. And you have made the operation of this really simple and easy to use. So let's walk through some of the features you've built into it.
Okay, sure. So when you look at some of the features, first of all, you would look at your chamber or your boards in your chamber. And what we do right now, this is 2 boards that would be in that chamber, mm-hmm. and you've got 4-channel boards. And you can see this green and yellow. So what we do is we can set a good condition, which would be a green, a cautionary condition, which
right.
would be a yellow, or a fail condition, which would be a red. Mm-hmm. So if it were running out on a production floor, as the boards are running, after each measurement, these stoplight type conditions mm-hmm. will come up to give a technician an indicator how the test is running.
So it runs basically, you'll have a red, green, and yellow indicator, a traffic light system, if you like.
That's correct. And then you can look at the test card. So here's an example of a test card that ran over 168 hours. And it's got 4 conditions, and you see your fail condition, your cautionary condition, or your good performance or desired performance zone. And in this test, what we look for is the stability of the channels. And each of these channels were pretty stable. Where we see failures is that, let's take, for example, we're running a test and we see a drop in insulation resistance. That's an indication that there's an electrochemical interaction going on. We're growing a metal dendrite.
Right.
And if we see that, and the way this test runs is that if you drop into that fail zone, you failed the test.
Right. Right.
So the instrument, it charts out, and then it also calculates the statistics. And when we set that red, yellow, green, we can set it to any one of those stats and how we want to run it. It allows you to configure your settings, so you can configure your pass fail. You can configure how long you want to run it, your health indicator, the type of board that you're actually running. Then it basically it will allow you to custom chart. So if I wanted to just look at this channel A, I could submit a custom chart, and there it is. It calculates the data grid, so all the data is there. So if an engineer wants to actually create his own data analytics, he can do it. And then it writes the report. So when it writes the report, you can actually open a test if you wanted to. So this is the test that I'm showing. I could open it. Or if I went to the report, I can actually view the report. And this is the report on screen, but it allows you to download it as a PDF. It's going to show you the conditions, the validation, the channel overview. It's going to give you an event log. So it gives you all the information that you want just almost instantly.
Okay. So when it comes down in that PDF report, though, does it gives an image of the actual test coupon and the result you got on it?
Yes, it does. Let me give you an example on the process control. So on the process control, as the test is run, it's basically going to build your X bar R chart. And based off your upper and lower limits, you set that when you run it based off your validation. And the idea on process control is we'd want to run that. It's a 2-hour test. And what we're looking for is, do we see any drift? In this case, we don't see drift. We see a very stable. It's going to calculate your CPK. And so it's going to essentially allow you to monitor your process. The real power is that when you build an assembly, there's multiple process steps. So you can track each of those process steps, and if you see something that's starting to drift, you can take action to correct it.
Right. That's excellent. So you've got full traceability here, that this can be held in a log for however long you ever need it.
Absolutely. The other features is that in the software you have this settings menu, which allows you to look at your user preferences, like, for example, your measurement units, your temperature, decimal points, whether you want to have your current in milliamps or amps. You can set your y-axis, your activity. You can set your test settings for your recipes for your boards, your SPC, your chamber. It gives you great ability to set up almost any condition that you want. You can set up your environmental chamber with your environmental tolerances. You can set up your network settings. So, for example, this is a Bluetooth type machine, so you can set it up to your network, and if you can log into your network, you can log into it anywhere in the world on your cell phone, your computer. You can, and I do that all the time when I'm actually starting to write reports from the testing services we do. You can go in, you can log into the machine and do a cloud update. You can. This is more for your IP that they can set it up. There's a support area on here, and in the support area, It actually goes through all the different phases of the machine, and then there's an update section to where, as we get software updates pushed out,
It can be automatically updated.
So the machine is really configured to be the whole product.
Right.
It actually can go in, do the work that it's designed to do, and a technician can run this machine.
Very intuitive software, Mike. I have to say that. But but this system also it does two test processes. You can be running your tests in the chamber, but then you can also do some process tests. So can you explain how that works?
Yeah, so when you ever have a chamber, you're typically running this at a temperature and humidity. So here, the chamber's not running, but we've got it set for 40 degrees Celsius, 90% relative humidity. So if you look inside the chamber and you have your test boards, if you were to open this door, you're going to see a drop in temperature and humidity, which will create condensation. When you create condensation, you're going to get a drop in insulation resistance, which you'd never want to do.
Right.
With this software, it allows you to do multiple tests. So the way we configured the system on the side, we have these extension ports.
Okay.
And so these extension ports just unplug for a process control, and this is what we call an electrical twin. So you pattern these little electrical twins into your panel of production boards. You break them off, you just plug them in, and you set up your process control.
So these are little side coupons that you put onto the side of the board just to test any particular areas that you might have concern about.
Yep, and you can run multiple tests at one time. So you can set up a process control test while you're running a standard test.
Okay, so you set up on this side for an SIR test in the chamber or the process control test, just using this, which literally plugs into the chamber, but without disturbing the humidity and environment of the chamber itself.
Right. So the chamber is not a pressurized device. So you've got a 2-inch port. When you pull that out, we can pull that out for 2 or 3 hours, and it'll never vary the temperature and humidity.
Right.
So when you put your process control coupon, it only takes a few minutes to stabilize, and then we take the first 2 hours of that data, and we monitor that first 2 hours of the data, which gets plotted onto your upper and lower. So in this case, it would be averaged to the mean, and we use that for process control. It's a very effective way to do it.
It's incredible. So it's amazing how far this machine has come since you first started. So it's not only the machine has developed over the years, but you've also developed the coupon system quite extensively. So let's talk a little bit about that. You want to bring up some of the developments you've done on the coupon side? Yes.
So one of the things that we like to do, and if you look at our test instrument, you'll see that we like to build the coupons into a 4-channel coupon. The reason why we like to do that is if we go back to this card here, or when you have 4 different channels, you can plot out and you can see the difference between those 4 different coupons. And different coupons can have lower insulation resistance. The common test board, like the B52, the IPC test board, has up to 16 channels. Could you imagine having 16 plots on that? You can't decipher what's going on.
Exactly.
The other thing that we do with these is that we try to create these with components that are representative of the toughest components on a printed circuit board that can trap residue.
Okay.
So that way, if you qualify to the challenging components on your card, you can extrapolate to say that if you have a good residue condition or stable residue condition, you would have it across the whole board.
Right.
The other interesting development is that on this board we have these glass dummies, which are metallized using the thin film technology. This was developed by Honeywell FM&T in Kansas City. It is patented by Honeywell. We license the technology from them. But what's nice about these type of components is that as you run an SIR test, if you start to see leakage currents, you can visually detect it with a microscope without having to shear the component off. So you can see the dendritic growth patterns that actually start to occur if they were to occur.
And it's quite important because, you know, if you were to just run this test with these components open, in a sort of open comb structure, it behaves differently than it does once it's encapsulated.
Absolutely.
Yeah.
And the reason is that the standoff gap on these components is so tight that in some cases it may not fully outgas during that refill. So it could leave a residue that's more active.
Right.
So whenever, and I call that a 3D condition. When I look at a 2D condition like an open comb, you're going to get uniform outgassing, and so you would see much more stable performance than you would when you put these type of components on a circuit card.
Yeah. No, I think it's a great development. It really is. So that's interesting. So you create these coupons for customers to try and replicate the conditions they're going to have on their board.
That is correct. We have a full-time designer on staff, and so we can design the electrical twins, we can design custom test boards, we can design almost any component that's out there. So if a customer has a specific product that they're really wanting to understand, you know, electrochemical reliability, they come to us, we design the test coupons for them, and after that design, then they can populate them.
Right.
And if they have a machine, they can test them in-house. If not, they send them to us. We do SIR testing services, so we can do that testing for them, and we can help them understand how reliable their product is based off the material set that they're using to build it.
Right. Yeah, it makes perfect sense. So it's a great system all round, actually. So I want to congratulate you on the development of this, Mike. It really is quite impressive.
Well, it's a team effort. You know, what's really interesting about Magnalytix is it's a company that's owned by STI Electronics, which their competency has always been in high-end electronics.
Absolutely.
They build for the defense industry.
Yep.
They bring a set of competencies. And then Kaizen Corporation, which is the other piece, I mean, we have engineers who understand how to write software code, how to build equipment, and more importantly, we're in the cleaning business. So we understand soils, and we understand the risk of soils. So when you put the two groups together, it brings a unique company that has a lot of knowledge, expertise.
Absolutely.
And so when you look at the finished product here, this is a finished product of a team effort of people who've actually, you know, looked at this and said, how do we do it? How do we make it reliable? And how do we make it easy for a technician to utilize the tool? Yeah.
No, as you say, I mean, it does exactly as you stated. I mean, it's easy enough for an operator to use, and you know, once you get it set up correctly, you know. But no, very impressed, and I wish you every success with it going forward. I know you've got quite a few of them out in the field already.
Yes, sir.
And you know, hopefully before long you'll have many more.
Well, we appreciate it, and when we get an opportunity to, you know, to talk with you and get more and more people to understand what it is we're doing, that really helps, you know, for people to truly understand the benefits.
Yeah, that's true. And I think you did a good job today, actually, of explaining it in fairly easy terms. So I'm sure there's lots of people out there that understand exactly how this works now.
Yeah.
Expand your inspection capabilities. The Mertec MV6 comes fitted with a best-in-class high-performance 18-megapixel camera. This provides inspection in 5 directions using top-down and 4 angled cameras simultaneously, finding defects that a single camera can't detect, such as OCR and QFN solder bridges.